Okay, so in video one of this derivative series, we had a look at the linking the spaceship through, linking the idea of the spaceship to the idea of the derivative. And we looked at how far above the front of the spaceship was, dy, was in, and how far in front of it, of the back of the spaceship it was, without dx. In the second video, we kind of put some spaceships on a graph, on a quadratic, to find the derivative at lots of different points. So we launched the spaceship from this point, in line with the graph, to find the derivative at 0, 2. We launched the spaceship from this point on the graph, from 5, 9, launched it in line with the graph to find the derivative at 5, 9. And we launched the spaceship from the very top of the graph, in line with the graph, from the point 10, 12, to find what the derivative at the point 10, 12 was. We found the derivative at point 0, 2 was 2 over 1. We found that the derivative of the whole equation at point 5, 9, by launching a spaceship, we found it was 2 over 2, which was equal to 1. And finding the derivative of the graph at 10, 12, from the very top of the graph, we found out that the derivative at the top of the graph was 0 divided by 4, which was equal to 0. So in this session, we're gonna explore something different. So you might be getting pretty bored of drawing spaceships on graphs now. So we might want to ask the question, wouldn't it be cool if there was another way to work out how the spaceship was pointing without having to draw the spaceship, right? So wouldn't it be cool? Let's write that down. Wouldn't it be cool if we could work out how the spaceship is pointing without drawing the spaceship? Well, the answer is yes. That would be extremely cool. And turns out there's a way to do it. So what's our original equation? So our original equation, let's change colors. Original equation was our quadratic, wasn't it? And that was y equals negative 0.1 x squared plus 2x plus 2. So that's our original equation. And we launched our spaceship from lots of different points on this equation, didn't we? Now we're going to explore something which is the derivative equation. Some of you would have worked out how to take derivatives in the past. I'm not going to go into the derivatives here, how to actually take this, but I'm going to do just this one example. So as we mentioned earlier, our derivative we often write like this, y1, or as dy over dx. So that's the derivative. We're going to keep it as dy over dx, dy over dx. And for this original equation, the derivative becomes, we bring the 2 down to the front, and we have negative 0.1 times 2 times x plus, and we drop the power there of x. Again, the scope of this lesson isn't covering how to do this exactly, but I'm just doing it here. Negative 0.2x plus 2. So this is our dy over dx. Now I'm going to just cross out this line because that's just working. So we can just remember that that's working. But this is our gradient equation, and this is our original equation. Okay, so, or what's going on? I'm drawing squares. Original equation, and that gave us this derivative equation. And the amazing thing is that this derivative equation is going to tell us how the spaceship is pointing without drawing the spaceship. So we considered launching the spaceship from 3 different points, didn't we? We considered launching the spaceship from the point where x equals 0. And notice we don't have to care about what y is, because in this derivative equation, we've only got an x. We've got this dy over dx, but that's what we're trying to find out. But we don't have an y, so we just have to worry about the x. So the x values of where we launched our spaceship from originally were, okay, newer color. What about a highlighter? Okay, that didn't really work very well. Our original place was, let's use this color. First out, we launched it from 0. Then we launched it from 5. Then we launched it from 10. And we can see those numbers down here. First we launched it from 0. Then we launched it from 5. And then we launched it from 10. So we're going to use now this derivative equation to tell us how the spaceship was pointing at 0, how it was pointing at 5, and how it was pointing at 10. So first let's consider in green, we'll stick with our green for our 0. So we can say, how was the spaceship pointing at x equals 0? Well, when x equals 0, all we have to do is say dy over dx equals negative 0.2, 0 plus 2. So you'll notice that where the x was, I've subbed in the 0. And what does that equal? Well, that just equals negative 0.2 times 0 is 0 plus 2 is just 2. So this tells us that this derivative equation tells us that when x was 0, when we launched our spaceship from the x value 0, the spaceship was pointing to. The spaceship's front was above the back and the back was behind the front by 2. Let's check that. Let's go back to where we were. Well, this was our first one. We launched it from 0 and we found that the answer was indeed 2. So we've just found out how the spaceship was pointing without having to draw the spaceship. Our next one, we launched it from 5. It's not very clear. We launched our spaceship from x equals 5. So let's try this again. So how was the spaceship pointing at x equals 5? Again, dy over dx equals negative 0.2. This time, instead of putting our 0 in where the x was, we put our 5 in where the x was. 0.2 times 5 plus 2. And so negative 0.2 times 5, well, what's that? We have 1/5. 0.2 is 1/5. So we've got 0.2 plus 0.2 plus 0.2 plus 0.2. 1, 2, 3, 4 plus 0.2. 0.2, 0.4, 0.6, 0.8, 1. 1. So this becomes 1 plus 2. Oh, it's negative 1 actually. And so negative 1 plus 2 equals 2 minus 1, same thing, 1. So it tells us that our spaceship was pointing 1. That's the way our spaceship was pointing when we launched it from 5. So let's go back to our launching from 5. So we launched it from 5 and we found out that it was 2 over 2 and it was in fact 1. Right? Amazing. Next thing, finally launching it from 10. Launching our spaceship from x equals 10 because we only care about what x is because we've only got an x in the derivative equation. So we're using orange here and we launched our spaceship from 10. So how was spaceship pointing at x equals 10? Well, dy over dx equals negative 0.2. Writing out our derivative equation, because the derivative equation tells us how spaceship is pointing at x equals something. That's what this does. Tells us how the spaceship is pointing at x equals something. So we've got 0.2, we launched it from 10, and we've got our plus 2. And so 10 times 0.2 is negative 2, plus 2 equals 0. Spaceship was pointing 0. And was it? Yeah, it was. So this video has really shown us that, wouldn't it be cool if we could work out how the spaceship was pointing without drawing the spaceship? Turns out we could. What we did was we got the derivative equation and found out that what the derivative equation tells us, dy on dx equation tells us how the spaceship is pointing at any x value. In other words, we can launch the spaceship from anywhere on the graph. We can launch our spaceship from anywhere on the graph, and the gradient equation, the dy over dx equation, will tell us how the spaceship was pointing. Let's do an exploration. What about if we launch the spaceship from, let's have a look, from 15? No, let's just go from 20. If we launched our spaceship from 20, so if we launch it from 20, how is spaceship pointing at x equals 20? Well, our dy over dx, the general equation is negative 0.2 x plus 2, isn't it? So now we just have to substitute in, it's a different color, we just have to substitute in this 20 into here, and so we get dy over dx equals negative 0.2 times 20 plus 2, and well, 10 times 0.2 would be 2, so all we've got here is negative 4 plus 2, that's 2 still there, and that equals negative 4 plus 2 is the same as 2 minus 4. 2 minus 4 is negative 2. And so that's the way the spaceship would be pointing there. And you notice that it's at exactly the same height as this one. It's exactly the same height as this one. And this was 2, and this is negative 2. So we're seeing a kind of a cool, interesting result there. So video 1, learn about the spaceship. Video 2, learn how to draw the spaceship and launch from different points. Video 3, we've learned how to actually work out how the spaceship's pointing without having to draw the spaceship. And in video 4, we're going to link in the idea of the spaceship to this idea of rate of change, which we often hear about. The icing on the cake.